Practice is the cornerstone of mastering any physical skill. Whether it's playing the piano, shooting a basketball, or performing surgery, consistent practice is non-negotiable. But what's happening inside our brains when we practice? Our brains are incredibly adaptable organs, constantly rewiring themselves in response to our experiences. This process is particularly evident when we engage in repetitive actions, like practicing a physical skill. Two key players in this process are grey matter and white matter. Grey matter, made up of neuronal cell bodies, is responsible for processing information. When we learn a new skill, our grey matter is highly active, working hard to understand and execute the movements. White matter, on the other hand, acts as the communication network of the brain. It is composed of axons, which are like cables that transmit signals between different areas of the brain. As we practice, our brains don't just get bigger or stronger, they get more efficient. This efficiency stems from the strengthening of connections within the white matter. Specifically, practice enhances the myelin sheath, a fatty substance that surrounds axons. Imagine the myelin sheath as insulation around an electrical wire. The thicker the insulation, the faster and more efficiently the electrical signal can travel. Myelination is a crucial process in skill development. As we practice a movement, the myelin sheath around the axons involved in that movement thickens. This thickening allows electrical signals to travel faster and with less resistance, leading to smoother, more coordinated movements. Think of practicing a tennis serve. Initially, the movements might feel awkward and disjointed. However, with consistent practice, the neural pathways responsible for the serve become increasingly myelinated. This enhanced myelination translates into a faster, more fluid and effortless serve. The more we practice, the thicker the myelin sheath becomes, and the more automatic the movement becomes. This is why experienced musicians can effortlessly play complex pieces, and skilled athletes can perform intricate maneuvers with seemingly little effort. The beauty of myelination is that it's a continuous process. As long as we continue to challenge ourselves and practice regularly, our brains will continue to adapt and optimize the neural pathways associated with that skill. This means that there's always room for improvement, no matter how proficient we become. The term muscle memory is often used to describe the phenomenon of skills becoming ingrained in our bodies. However, muscles themselves don't actually have memories. Instead, what we perceive as muscle memory is actually the result of strengthened neural pathways in the brain and spinal cord. When we practice a skill, we're not just training our muscles, we're training our nervous system to control those muscles with greater precision and efficiency. This neural training leads to the creation of motor programs, which are essentially blueprints for movement stored in the brain and spinal cord. These motor programs allow us to execute complex movements without having to consciously think about every detail. For example, when you first learned to ride a bike, you probably had to consciously think about pedaling, balancing, and steering all at the same time. However, once you mastered riding, these actions became automatic. You no longer had to consciously think about each individual movement because your brain had developed a motor program for bike riding. This program allows you to effortlessly coordinate the necessary muscles and movements, freeing up your conscious mind to focus on other aspects of riding, like navigating traffic or enjoying the scenery. While practice is essential for skill development, not all practice is created equal. To maximize our learning potential, we need to engage in deliberate, focused practice. This means minimizing distractions, setting clear goals, and actively seeking feedback to identify areas for improvement. One effective strategy is to break down complex skills into smaller, more manageable chunks. By focusing on mastering one component at a time, we can gradually build up to the full skill. Another important aspect of effective practice is repetition. By repeating a movement or skill multiple times, we reinforce the neural pathways associated with that action, leading to stronger and more efficient connections. However, it's crucial to avoid mindless repetition. Simply going through the motions won't lead to significant improvement. Instead, we need to practice with intention, focusing on our technique and striving for accuracy and precision. Incorporating variability into our practice sessions is also beneficial. This could involve practicing in different environments, using different equipment, or varying the speed and intensity of our movements. By challenging ourselves with novel situations, we force our brains to adapt and generalize our skills, making us more adaptable and well-rounded performers. Remember, the key to mastery lies not just in the quantity of practice, but also in the quality. By practicing smart, we can unlock our full potential and achieve remarkable feats of skill.